So chapter number 13, page number 215. Passing parameters. Now you guys already know what are parameters, right? Can one of you tell me what is a parameter?
Something that is passed through a command and or function.
Okay, anybody else has a different answer?
A value that a calling program passes to a called program.
Okay, okay. Anybody else? Parameter is basically a value that you pass from an outside to an inside. That outside to an inside value could be in the form of a function, a procedure, a method, or in this particular case, when we talk about control language, you can pass parameters into a program. Can you pass parameters into a Java program from outside?
Into a Java program?
Mm-hmm.
Yeah.
Yes, yes. And where will you pass that? From outside of the program into the program? No, nobody is talking, right?
I'm not sure.
Check the chat.
In the main.
In the main, you see the parentheses in the main for the parameters?
Mhm.
That's exactly the purpose of that parentheses is that you can pass values from outside of the main into the main, in the body of the main. But generally, we don't do that anymore. We used to do that in the good old days when we would call a Java program from a command line. So we used to type Java and the class name and the param1, param2, whatever, however many parameters you want to pass. So the Java command would be an executable file to run a class, and the parameters will be passed into this array called args, and then you will be able to pull those values out in the main. So we don't do that anymore. Maybe for testing purpose, we may do that, but we won't do it otherwise. But as far as CL is concerned, control language is concerned, you can call the program, you can write the program name, and then you can pass parameters. Depending on the data type, you will either enclose the values in single quotes or not enclose the values in single quotes. But the number of parameters that you're passing will match the data types and the number of parameters in the actual program line. So page number 215 talks about that you can use the call command to call a program, or call PRC command to call a bound procedure, or a transfer control command. The calling program or procedure passes the values to the called program or procedure. A value that a calling program passes to a called program is commonly called a parameter. So the definition of parameter, according to CL, is defined right on page 215, that a value that a calling program passes to a called program. A parameter controls the actions of a program by providing an input value to the program. You can use parameters to share information between two programs. So that's one of the purposes of a parameter, is to share information. You specify parameters by indicating their values within the parm keyword in the call procedure, transfer control, and PGM commands. So at the bottom of page number 215, you see a code snippet, which looks like this. Are we passing any parameters?
Name.
Are we passing any parameters? Yes or no?
Yeah.
Yeah. Are we receiving any parameters?
No.
No. So we are only passing a parameter from program by calling another program called PGMB, and we are passing a parameter using a local variable name, which is declared with the value Bob. So one program can call another program and pass parameters. Okay. Now, have a look at this guy. This is slide number 3. So what you see in the background is the program 1, and what you see in the foreground is the program number 2, which is getting called by the first program, and the parameter is getting passed. Now the receiving parameter name also needs to be declared. It will receive a value Bob from the other program, and then it'll display my name is, and it'll display Bob. Did everybody follow that? So far, so good?
Yep.
Okay. Now, when you're passing a parameter, you can pass a parameter in the form of a variable, as you saw in the previous example. You can also pass a parameter in the form of literal string or characters, what we call them here. So as you can see over here, the caller passes Monday, Tuesday, Wednesday. The receiver receives them in variables day 1, day 2, day 3, which needs to be declared in the program. Remember that in CL, the parameters, when declared, do not have the data type. They only receive the data type in the body of the method or the program. Just like you can pass character constants, right here. Hold on a second. Okay, call program or procedure must declare the parameter as character so that it can receive characters. Moving on to slide number 7. Character constants are passed with a minimum length of 32 characters or the actual length if longer than 32 characters. Now I'm looking at page number 217 in the book. There is a program which is passing 3 parameters, which is expecting to receive 3 parameters, name, number, and flag. So any of the calls that you see right at the top of page 217, if you pass it in the correct sequence, the Christine goes in name, the number 22.5 goes in number, and the 1 goes in the flag, because the parameters must be specified in the correct order. But if you do what is being done in the second call command, if you were to use this call command, the data types of the parameters would not be consistent between the call command and the program, and the call to the program would fail. So you have to make sure that the parameter that you are passing are in the same sequence as the receiving end. Otherwise, things will fail. Similarly, on page 217, it talks about to pass constants as parameters to a called program, you simply place the constants within the parm parameter of the call command. You can specify one parameter as in, for example, if you're passing Monday, or multiple parameters, as you can say Monday space, Tuesday space, Wednesday. We already saw that, okay? Okay, now moving on to page number 218. I'm looking at the bottom of page 218, which is reflective of what you see in slide number 7. You also must be aware of how CL passed character constants of various lengths. All character constants shorter than 33 characters are sent to the call program with a length of 32. Position beyond the length of constants are padded with the blanks up to a total of 32 characters before the parameter value is sent to the call program. If you specify a character constant longer than 32, it is passed to the call program in its exact length. So this basically is one thing to keep in mind. That's why the illustration on page 218 towards the bottom pretty much shows you that. that you're passing Mary, Joe, Billy, Rumpelstiltskin, and character constant longer than 32. So there are 5 parameters, okay? All 5 parameters will be received differently. Mary followed by 28 blanks, Joe followed by 29 blanks, Billy followed by 27 blanks or 26 blanks. Same goes with Rumpelstick, whatever. And then character constant longer than 32 will go as it is with no blanks. In the receiving program, these parameters might be declared using the following statements. So what happens here, the Mary, which was 32 when it was passed, will be received by param1, which is 10. So now the Mary will be Mary plus 6 spaces. So you will not run into any errors. So this is just to demonstrate the point, okay? So how about you guys go ahead and read pages 218 through 220. Read pages 218 through 220. In the meanwhile, let me see who else arrived here. Anybody else came in while we were talking about chapter 13? Oh, Victor. Victor is here. Okay. Okay. So we are still missing Mason. We're still missing William and Jonathan. I saw that the list grew and then shrank again. Somebody else came in? Did anybody else join us? Okay, let me see through the list if you guys are not planning on speaking. Okay, is Jonathan here?
Yeah, sorry I'm late.
Yeah, I was asking, you should have spoken. Right? William is still not here. Okay. So let me know whenever you guys are done reading pages 218 through 220. Any questions? Those of you who are done reading it? So as we move on to now the logical constants, when you pass logical constants as the parameters, same rule applies as character constants, that when you pass them, they're sent as 32 characters with one, the first placeholder taken by the logical constant of 1 or 0, because as you can see over here on slide number 9, the logical constants are also passed in single quotes. So they're passed as characters of size 32. And on the receiving end, when they're, for example, received in parm1 or parm2, and parm1 is of type logical and parm2 is of type logical, then they're automatically, the remaining 31 spaces to the right are truncated, and the only first item gets transferred into the receiving end. So that's passing logical constants. You can read about that at the bottom of page 220. So it will be a quick read. It's just a paragraph. And then we will talk about decimal constants.
Which page? You stuttered for me in the last part.
Oh, page 220.
Okay.
Okay, so now let's look at the decimal constants. When you pass a numeric constant of decimal type, then you have to make sure that on the receiving end, the receiving parameters must be, you don't have a choice here. The receiving parameters must be declared to be of the type decimal size 15 with 5 places for the decimal part. So that's one thing different about CL compared to other languages that you know, that your numeric parameters are locked into certain size only. You cannot put any other size but that size. Okay, so the rest of the parameter passing works exactly the same way. Again, you can read about that on page 221. Okay. Now, the next topic, which is on slide number 11, is something that the chapter earlier on already talked about, which is passing variables as a parameter. As you can see over here that we are calling the program B, which is the one on the right-hand side, and we're passing a parameter called name with the value Bob. Again, this is just a repetition of the idea already talked about earlier on. Now, at the bottom of page 221, you can see that the author is showing you that you can pass one parameter or you can pass more than one parameter. And also, not all parameters have to be variables. You can do a combination of variables and constants as well. So you can see 3 different types of calls at the bottom of page 221. So now I would like you to read pages 221 and 222 under that heading, passing variables. Okay, so I've shared with you guys a job description in the chat. And along with the two documents and the email and the name and the position of the person who forwarded these to us. He is the General Manager, Services Operations for Data Financials Incorporate. So have a look at, read the material. The con, I'll just set aside a few minutes. Is it something that any one of you would be interested in? Is it something that applies to your expertise or your past knowledge?
That's a very specific experience list.
You know, I
Electric-
thought I would share it with you guys because sometimes, you know, we have students with different backgrounds. So sometimes some of these positions attract them.
For sure.
So is there anybody here who thinks that they can apply for this position or no? Well, next, I would like you to read pages 222 through 224 about the mechanics of passing variables. Pages 222 through 224. Assalam. most of you are done except for like 2-3 people still reading. Aiden, Christian, and Devin. Okay. Guys, before we move on to our next topic, I want you to look at a few pages in chapter 11. In chapter 11, let's look at page 178. Page 178, chapter number 11. It shows you that whenever a program calls another program, the caller goes down the stack and the called comes up the stack. When the called is done, it goes off the stack and the caller resumes from wherever it was processing before the call. And we have talked about that concept. It applies exactly the same way in other languages as well. Now I want you to look at page number 180, 180. When you are not making a regular call, rather you are making a call with the command transfer control, which is TFRCTL. When you make a call with the help of a transfer control and not the call command, it still works like a call command, but what happens is after the call completes, the caller is thrown off the stack. So it's not in the stack anymore. Only the called is running. So transfer control removes the caller from the stack and only the called is running. So when the called is done, you are not coming back to the caller. Is everybody clear about this concept? Because then we'll talk about chapter 13, page 224. Okay, so now page number 224, chapter number 13, which is the concept that we look at on slide number 12. And that is when you are calling a program and passing a parameter over to it, and you use a regular call command, you can pass variables, you can pass constants, you can pass combinations, everything works. But if you're making a transfer control, you can only pass variables as parameters. You cannot pass constants. You cannot pass a mix of a constant and a variable. What is the reason? The reason is when the call takes place with a regular call, the receiver is constantly backing on the memory of the caller. That's where the constant value is sitting. The problem with transfer control is when the transfer control happens, the caller is not in the memory anymore. So the receiver, the called, has nothing to pull the value from because the guy who was giving the value doesn't exist in the memory anymore. So that's why when you're doing a transfer control, you pass a variable into a variable. So that way the value gets transferred from one variable into another variable, and you are not relying 100% on the caller. So that's the point that transfer control talks about. The parameter variables must have been received. And also one more concept it talks about, the parameter that you're passing, or variable that you're passing, you cannot just declare the variable in the caller and pass. The caller must also have received that variable as a parameter to pass it. For example, as you can see in this little code snippet over here, there is a transfer of control from program A to program B. And in the program B, we are passing the parameter name. Name is not just declared, but name is also received as a parameter. Okay, so why you are doing this approach? Because again, if it's a locally declared variable and not a parameter passed variable, then again, the receiver will rely on the memory of the caller, and the caller goes out of the scope at the end of the call. So that's why things will not work out. So the author gives you a couple examples on page number 224. He shows you an example of a program where the program doesn't receive any parameter, but it makes a call through a transfer control to program B and passes the parameter cus number. That call will fail. The second thing the author shows you on the same page is that he receives a parameter, cus number. But what he does in the transfer control, he passes the cus number and also he passes a constant. That will also fail because you cannot pass a constant. You can only pass the parameters that you have received, not local variables, not constants. Okay, so now I would like you to read this heading, page 224, 225. The topic of passing parameters using the transfer control command. Okay, so now we will talk about the submit job command. Now, as we learned in the earlier pages, that whenever you make a call from a caller to a called, there's always a pointer. The memory pointer back to the caller's memory is where the called is pulling the values from. That's why we want, in case of the transfer control, because the pointer will not be there, the caller will go out of scope, we want it to be the parameter variable that is passed over. So now comes the question that if your program runs a submit job command, and that submit job command actually makes a call to another program, then comes the question that, okay, submit job will submit a batch job, and your program is right now running in an interactive job. So batch job means it will run later on. So when it runs later on, your program will not be there. So how is it possible that the later on running program can point back at the memory of the interactive program that is not even there because you logged out? The answer to that question is, when you submit a job from within a program and make a call to another program, the system is smart enough that it knows that it's an interactive job that is initiating a batch job. It will not build pointers anymore. What it would do is it will change all the variable values into constant values and will literally transfer those values into the submitted job program, so that the submitted job is not looking back to the caller with pointers, rather will hold the values locally so that whenever the job goes running, those values will be available to it. Does that make sense to you guys?
But it only does this when you submit a batch job within the program, or you call to.
Say that again, Gashi?
But it only does this when you submit a
Right.
batch job for it to call another program.
Exactly, because that's the only time when the called will need values from the caller. And the caller doesn't passes the values, it only passes the pointer. And in this case, the pointer will not be there when the submitted job runs. So it will transfer all those into actual constant values and hand it over to the batch job. So there'll be no pointers back. Yeah.
Okay.
Everybody else understood the concept here? Okay, so now I would like you to read about this in the book. That will be pages 225 and 226. And then also there's an additional topic that I want you to read from page 227, which is about hexadecimal notation, followed by read chapter summary, page 228. So. Okay, so Aiden, Christian, Jonathan, everybody's done. Okay. Okay, cool. So let's do two things. 1 minute. Let me stop the share. We will do two things. We will set aside some time till 4 o'clock with a combination of break and your quiz. I know the quiz for this week is a bit longer quiz. You guys can get started on this quiz. If you do not get to finish it in class, you can always continue after class. But at least you will get started with it, because I've noticed that sometimes when I give stuff for home, people come back next class and they haven't done a thing. And then they're falling behind. So that's why I want you to at least get started with this. So you manage your break plus the quiz time, and I will see you guys at 4 o'clock. It's under this week, the quiz for chapters 10 and 11. How about you, Christian? So in this simple program, we simply wrote a program where we are receiving a parameter, library, that we're declaring on line number 6. And then we are using that to display the library. So after compiling, I ran this by issuing the command call the program name, and then my parameter was Yusuf S, because that's the name of my library. When you guys run it, you pass your library name. That library name will be received by the parameter on line 5, which will then give it over to the display library. As a result, I will be able to, when I run this, see the contents of my library. So F3 will take me back to the previous screen. So Victor, let me know when you're ready. And let's check to see. Christian, can you hear me, or did you step out?
I'm ready.
Okay, Victor, go ahead and share your screen. Okay. So where were you getting the error message? This one. Okay. Click OK. Okay. But did you try running the program? Did you try compiling the program? Oh, hold on. Can you see? I told. Okay, hold on a second. Can you close RDI and reopen it?
Okay.
Yeah, just close it, exit out. Don't close the browser, just close RDI and just reopen the RDI. Yep. Aiden, what is yours returning then? Hold on a second. Hold it there. Can you click in your source code, please, for me? Yeah, double click on that. SP prog 22, 23.clle. Okay, now it is in the, okay. Can you double click on, can you scroll down in the list on the left? Can you scroll down? Okay. Okay, now can you identify that number 23 and open it for me? Did you double click on it?
Yeah.
Okay. Now click the compile tab. This compile option is now available to you. And now compile it. Okay, now click OK, that's fine. And then go to the green screen tab. Log in. Aiden, when you are calling your program, are you passing your library in single quotes, right? You wrote 5833, you wrote 2 3s, right? I think it's only with 1 3 your library is, correct? Okay. Hold on a second. Can you hit F3 here, Victor? Okay. Oh, okay. Now go to the end of this call. Just move your insertion point to the end of this call. Remember okay, now go to the source code so that you can see where we are making the mistake. Look at the very first line, PGM. Is it expecting a parameter?
Yeah.
Yeah, okay. Now go back to the green screen. Are you passing one?
No.
Okay. So no, it has to be in single quotes. Okay, single quote, your no. Your ID, which is the name of your library, ITPA, and your 3 digits and single quotes, and enter. Okay, now it basically, it received the name of the library in the parameter, and it gave that over to the command display library, and that's why the display library showed you your library.
Okay.
Okay.
Thank you.
Did you not follow it when I first explained it, that you have to pass a parameter?
I didn't catch that part.
Okay. So pay more attention, because I said it at least 4 or 5 times. I also wrote it in the comments.
Recording in progress.
Okay, Aiden, you got it now? What do you mean it's acting funky? Is it working or is it not working? Okay, can you share your screen, please, Aiden? I need to see your source code first, please. Oh, can you go back to your green screen? Oh, you need to leave a space after 23 and between the parameter. Yeah. Otherwise, it wouldn't know where the program name ends and where the parameter starts. That's it. Okay, guys, let me share my screen again. I need a little bit more attention and concentration from you guys, okay? Because otherwise, you know, we'll not be able to write much code. In 24 minutes, we just wrote 4 lines. That's not a good pace, okay? I'm writing smaller programs so that you guys can do programs quicker, but you guys are making little mistakes that you should not make 12 weeks into the course at this level. Okay, so we are now creating a new program SP22 program number 24. And I would expect you guys to pay more attention to this code when you're writing it. So when you run this program, again, you will be required to pass a parameter. Just keep that in mind. So the variable that I declare in my list of parameters, I have to make sure that I declare it and now I will declare some additional parameters. So I declare a total of 3 parameters. One is, three variables. One is of the parameter type, one is the logical, and one is the character. In this program, we will be doing some exception handling or error handling as we learn in chapter number 12. So in your books, I would like you to go to page 467. Page 467. What is the second command discussed on page 467?
The check object command.
The check object command. Okay. In the check object command, do you see error messages? What is the first error message and what is it used for?
In case the object cannot be found.
Thank you. Is that something that can happen in the program that I'm just writing, that if I check for an object, is there a possibility that the object not found?
Yeah.
Right? Because I'm passing the name of a file. So whenever we pass a name of a file, most likely I want to work with that file. And if I'm working with the file and a file is not found, then it will generate the error message. So according to the syntax shown to me on page 467, I will start out by calling the command check object. That's the first thing I do. Check object. What is the first parameter of check object? On page 467.
It's the library name.
And
The object name. Sorry, I thought there was.
it's actually the object name, but you can always create it as a qualified name by making library name part of the deal. Okay. However, in our case, for us, it will be the parameter. What is the second parameter of the check object?
Object type.
Object type, okay? So when I'm checking a file, the object type will be file. Because the definition of file in this environment is not the same as the definition of file in Windows. Here, file means something that can hold data. That's it. That's basically is the only thing that you would call a file. Now, an error can occur. So I'm going back to page to chapter number 12. And let's see, in chapter number 12, let's look at page number 198. Let's go back to page 198. On page number 198, you will see the syntax of creating a monitoring message. What is the first thing that you write when you're monitoring a message?
Message ID.
Before that,
The mon message keyword,
the mon message. What is mon message? It's not a
monitor
keyword.
message,
It's not a keyword. What is it?
an abbreviation for monitor message.
But what is it?
I don't know.
Come on. Hey, Tony,
And
come on.
a command.
It's a command. Next time, do not say that because that really makes me feel bad. Why it makes me feel bad? Because you need to understand this right from the intro class, that anything your instruction starts with is what? Tony?
A command, obviously, but I did not assume that the question was going to be that broad. I'm sorry.
Well, that is always the case. Just remember that. Okay, what is the first parameter of the command monitor message? The first parameter,
Message ID.
message ID. And which message ID did I identify for you guys on page 467? That's also on page 198. If you're looking at the examples down below on page 198.
CPF 9081. 9801.
Right, okay. And what is that used for? And what is that used for?
Object not found.
Object not found. Okay, so we are monitoring the message ID CPF 9801. Okay. When so-and-so error occurs, I want to execute some code. Now, the examples given to you at the bottom of page 198, they pretty much are like, okay, if you want to run a single instruction, you just write execute, and in the parentheses, you just write that command and you get rid of whatever you wanted to do. However, if I want more than one instructions to be written out, what do? Check the bottom of page 203. Look at the bottom of page 203. Look at that code snippet and tell me if you want your monitor message to run multiple instructions, what do? Bottom of page 203.
Do.
You type do, okay. Between the exec, you type do. And then, of course, you have to close the block with undo. And now between the two, you can write multiple instructions. Send program message, cannot find file. Go to end. So just jump to line 112. If the file is found, then we will not run this program message. Rather, we will run a different program message. Program completed successfully. Oh, my bad. Hold on a second. No, what did I do wrong here? Oh, I should have used an asterisk. I use an ampersand asterisk. So again, when you are calling the program, your call instruction will be like what? Call SB22 prog number 24, and then you will pass a parameter. So for example, I have a table in my database called books. So if I run it with the books, it will come back saying that file found, or program completed successfully. However, if I do not have a table called books, it will come back with an error message saying cannot find file, followed by the name of the file. So you guys can try it with one of the physical files that you have, and also try it with the physical file that you don't have. And please give me a green check when everybody is done, whoever gets done.
It just tells me that the program is completed successfully, and it does not tell me whether or not I can find the
Did
file.
you pass a name of a file?
Yeah,
Okay, and did that file existed?
yeah.
Then try to also pass a file that
doesn't-
doesn't exist.
It doesn't tell me whether or not it even exists. It says program completed successfully. It just jumps right down to end.
Go ahead, share your screen so that we can, like, I can see what you're doing. Okay, first let me look at your source code. Okay. Okay, now can you go to your execution mode? Okay, hit F9. Okay, so now change it to books 2. And close the single quotes, enter. See? That's it. You got it.
All right, I didn't know that I had books as a.
Well,
Because
you might have created it. It's probably could be a physical file or a table you might have created in the past in one of your classes. Okay, so you're fine. Okay. I'll share my screen again for anybody who's still coding. So Tony, can you also give me a green check so that I know that you're done too? Okay, so we have Christian, Devin, okay, Jacob, Luke. Looks like Christian is the only one left.
I'm almost done with mine.
Okay, make sure that you also run it for both cases. Yes, Christian.
So it says label end does not exist.
Okay, do you have a label called end like I do on line 1300?
Oh, I missed start and end. Okay.
Mhm. Okay, did that work now?
Yep.
Okay.
So-
So guys, now we will save this example as, click File, Save As, and we will change the 4 to a 5, so it'll be 25. And again, as I told you guys before, please make sure that you have 25 in the list on the left, so that you don't tell me later on that, oops, it was never created. So once you can identify that the 25 is available to you in the list on the left-hand side, after you save as, now we will get started here. What we will do different in this example is that we will create several labels. And instead of writing the monitor message tackling statements over here, we want to create a separate error handling routine. So what we want to do is we want to make some labels right past the send program message. I'll create a label called end it, and this will have my return instruction. Then I'll have another label called error. Before I code my error label, let's look at the book, page 206. Page 206. There is a receive message command discussed on page 206. That was last week's chapter, chapter number 12. What is the purpose of receive message command?
To receive the error message.
Exactly. So whatever error message was generated by the system, it helps you retrieve that error message into a local variable. So we have a local variable declared on line 400 called MSG. This is the variable in which we will receive the message. So receive message, the message type is the last message, and we want it to be placed in the variable message. And then the send program message will be so first complete the label error and the code in it. Then we will make some modifications to the code in the start. Okay, so whenever you are done with the lines 1101 through 1104, now I'm making some changes to lines 700 through 1000. On line number 700, instead of do, I want to redirect my user to go to the error label. So I'll literally type go to error. So it'll jump to the error label, which is line 1103. As a result, lines 800 through 1000 are not needed anymore. Therefore, I'll go in the column section. And how do I delete 3 lines?
D3.
D3. Yep. So I make sure that you are not on the mon message line, you are on the send PGM line. And then when you type D3 in the column area and hit enter, 3 lines will be deleted. And this is what will be left. Let's save the changes. Compile the program. And now we will run the program. So if I pass a file that I don't have as a parameter, I'll get error message, object books2 in library is not found. See, this is the message that I'm receiving directly from the system. This is not a user generated message, but a system generated message. On the contrary, if I pass an object that does exist, then it will give me that program completed successfully. So you can test this program with a parameter of like a file that exists and the file that doesn't exist. And please give me a green check when you are done with this program and you've executed it correctly.
So I'm having an issue when I call my program or the program. It takes me to display program messages.
Okay, so we have Aiden, Christian, Devin, 3 people Christian, Aiden, Devin, right? Yeah.
Are you able to hear me?
Now I can hear you.
Okay. So I ran the program and it says that it took me to a display program messages page.
Did you pass a parameter?
I'm not sure.
Then hit F3, go back and make sure that you're passing a parameter. Because see, when it says on the first line that the program expects a parameter, that means you have to pass one. If you do not pass a parameter, it will take you to that screen.
Got it. So I can type anything in here.
How did you run the previous one?
I just called the program without any parameter.
Really? We have been doing parameter passing from last 3 programs. Christian, show me your screen because, you know, I mean, I don't know what you're doing. Okay. See, on very first line, it says it needs a parameter, right? And
Yeah.
what kind of parameter is it asking for? A file name. And what is the data type of file?
Sorry, what?
What is the data type of the file?
I think that's string or character.
Character. Okay, now go to the Death Star tab. If it's a character, you need to enclose it in single quotes, right? And you got to write a name of a file, which could be a table or a physical file or a logical file. I had a file by the name of books, so I passed that. So go ahead, you try with books. If you do not have books, it will give you an error. You had books, so it came back successfully. Now hit F9 and go to the end and change that books to a books 2 and close, enter. This time it came back with an error message saying the following object was not found. I remember I ran number 24 with a parameter for you. I think you forgot. Yeah, keep hitting F9 a few times. Keep going. Keep going. Keep hitting F9. That's it?
Yeah, I think so.
Okay. Because I remember I ran, you remember you shared your screen for 24 as well? And then you told me that, oh, you didn't know that you had books?
I don't remember that.
Okay, okay, maybe you did not then run it. Oh, maybe that was Tony. Okay, sure, that's fine. Go ahead. So all the programs that require a parameter, you have to call them with a parameter.
Okay.
Okay. Okay, guys, I wanted to do more program, but looks like we are already at 5 o'clock. So we will work with more programs next time. So in the meanwhile, guys, I would highly recommend for those of you who are falling behind in the coding to review the programs. so that you know what we're talking about. Because there's no point of me having to go through these tiny steps. I expect that everybody go through the examples during the week, and that's the whole point of making sure that you guys read the chapter in front of me, because that's the biggest complaint of the college, that people go home and don't read the chapters. So read the chapters, include examples, syntax. So when you are back in the classroom, I want you to be a little bit more prepared for the code. Because in 1 hour, we only wrote probably 15 lines of code. That's not good. So anyway, I'll see you guys next week, and make sure you complete your quiz. There is an assignment on chapter 13 that you need to work on. And I'll see you guys next week.
Right.
Thank you.
Welcome.
Have a good one.
Mhm.